Okay. So for today, this is your review for today. So whatever you guys want to look at, we mostly looked at in the last class. We mostly looked at equations that are quadratic in form because that's been the longest since you guys have seen that. So we mostly looked at these, but we can look at whatever you want. If you guys want to look at. Yeah, we can probably do that. So let's start with what's been farthest away from us, which is the solving equation of quadratic form. That was just from the last section of 1.6. So if you look at a problem like this one here, and I'll go play by play. So you have number 44 on page 169. If you guys want to practice these between now and tomorrow, page 169, this section here, we're number 144. Your textbook, I believe, provides solutions to odd number problems. If not both odd and even, you can try some of these around this. So let's say you're given a problem like this on the quiz. You may remember these. So this is not a quadratic, but it's quadratic in form because this guy is twice the power of that guy. First off, let's set it equal to 0. So we say, okay, I'm going to subtract 13x squared from each side. I'm going to add 9 to each side. So this whole right-hand side becomes 0. So you get to here. Okay? And so we have 4x to the fourth minus 13x squared plus 9 equals 0.
Wait. Why does the whole right side become 0?
Oh, because I subtracted 13x squared and I added 9 to both sides.
Okay.
So now you're here. So now, even though it's technically not a quadratic, it's quadratic in form because this guy is exactly twice the degree of this guy. So you can, in your mind, you can think of it like how you would go about solving 4x squared minus 13x plus 9. You can approach it the same way. So, long AC method. If you know tic-tac-toe method, go ahead and do that. But long AC is the way I've been teaching you, so I'm just going to stick to that. So long AC method says that AC, or 4 times 9, is 36. So I have to find factors of 36 that add to B, which is negative 13. So actually, I'll write that for this.
Wait, because yesterday you said you were going to show us the long AC and the difference between the long AC and the tic-tac-toe.
You guys want to see tic-tac-toe?
Yeah, like just to see the difference.
Which one do you think is easier?
I will demonstrate that real quick. So factors of 36 that add to negative 13. This is the process when you do AC method. Factors of AC, which is 36, that add to B, which is negative 13. And you go through, and if you listed all of them, you're only going to find the ones that work. There's only one pair that works, and that's negative 9 and negative 4. So then what you do, guys, let's refrain from all the comments too. What you do is you rewrite this as the sum of negative 9x squared and negative 4x squared. You can ignore the purple for right now, that's the next step. But all I'm doing when we did this is say, okay, I'm going to rewrite this negative 13x squared as negative 9x squared and negative 4x squared. That's all you're doing for the next step.
Wait.
And the reason you do that, just take it in, and then if you still have a question, please raise your hand. Now the reason you do this is because now it's going to work out. If you get to this point here, this thing is going to work out nicely for you. I can tell you that now. If you get to here, okay, you say, I'm good. You do this, and it doesn't matter how you write this. You could have wrote the negative 4x squared first, and then the negative 9x squared. It doesn't matter. If you factor by grouping, that's what we're doing now. You group the first two, group the second two, and then you repeat the same. Sorry, you don't repeat the same thing, not yet. You say, what is the greatest common factor of these two? So I know I just showed you, but if you look at these two, what is their greatest common factor? Yes?
X squared
x squared, so you factor that out. And what's the greatest common factor of these two guys? 1, yeah, that's it, 1 or -1. That's all you can do. So that's what we do. We factor out x squared from these two, leaving you this. Now I factored out -1 so that this would match exactly. This is how you have to do this long AC. You cannot just do, oh, okay, factors of 36 that adds -13. Oh, -9, -4 is right. Okay, x squared minus 9 times x squared minus 4, you'd be wrong. Because this is not 1. You can't do short AC. This is long AC method. This is what you have to do. Yes.
So you'll get for answers?
Yeah, okay, so this is a 4th degree, good. This is a 4th degree polynomial equation. So we could have up to 4 different, 4 unique solutions as possible. Yes?
Okay, so the partition 4x to the 4th plus 9x squared, that part, I have to keep forgetting the plus, and is it a -9 or a plus 9? Or do you have both of them?
Yeah, so that's plus -9x squared.
Okay, it's
Yep.
plus negative.
Yep.
Why did you put the, you put x squared and you put the bracket and then put -1? Where'd you get that from?
Okay, so now we're here. So we agree we factor out x squared, we're left with this. You can even do multiplication, right? I'll explain the whole line. So x squared times 4x squared is 4x fourth. X squared times -9 is -9x squared. So you know this is factored, right? So now this one here, if you notice, it's the exact opposite of the 4x squared minus 9, this -4x squared plus 9. Then by you factoring out -1, it'll make it the exact same. So that might happen. You might have the exact same already, or the exact opposite. If it's the exact opposite, you have to factor out -1 to make it. So now I did brackets just a point. You don't have to do brackets, but I'm saying look at this guy, and then look at this guy, and what is their greatest common factor? This is the part that repeats. You just took out the greatest common factor of each of these individually. Now look at both of them that have just now been factored, and what is their greatest common factor? And this will always work out when you have this situation here. Their greatest common factor is 4x squared minus 9, so I factor that out. I factor out 4x squared minus 9, leaving me what's in orange, x squared plus -1. So these problems, these equations that are quadratic in form is more, I think, of a review of long AC method than anything else. And then from here, if you continue this, now I can say this equals 0, or this equals 0. Yeah, I did. So we'll keep going. So this equals 0, this equals 0. Now solve for each one of those individually. This one here, adding 9 to both sides, divided by 4. So now I have x squared equals 9/4. Well, you need to take the square root of both sides and consider both the positive and negative roots. Because, for example, if I say x squared equals 4, what are the two real solutions for x? If I say x squared equals 4, what could x be?
Or -2.
It could be 2 or -2. Yeah, because -2 times -2 is 4, and 2 times 2 is 4. That's the same thing here is like, okay, x squared equals 9/4, so x equals to plus or minus the square root of 9/4. Yes?
Why didn't we just divide those and get a decimal? Are we not supposed to get a decimal?
No, I really wouldn't. I wouldn't do it just because when you take a plus or minus square root of a decimal, it can get even nastier. So I would just leave it as it is. Yeah, but you can write that as a decimal if you want to, for whatever reason, you want 2.25, and then take the square root of 2.25, you're going to get 3/2.
Okay.
So I don't care which way. I don't care if your answer is decimal form or fraction form. I'll give you full credit. Yes.
In order to get rid of a square, you have to square root it.
Yep. So in order to solve for x, if I know x squared is equal to this, I square both sides, but I need to do plus or minus square root because this is even.
Yeah.
Okay. Some of you might look at this and recognize, oh, difference of squares, which is good if you do. You should recognize and say, okay, 2x plus 3 times 2x minus 3, and still arrive here. That's fine too. But I'm showing a way such that if you don't recognize difference of square, you didn't memorize that special case, which you should, but if you don't, you can do it this way. This guy over here, solving for this guy by itself. Adding 1 to each side, and then now x squared equals 1. Taking the square plus or minus the square root of each side, you have, or taking the square root of each side but considering both plus or minus, you have x equals plus or minus 1. So there are 4 answers, there are 4 solutions. X could equal positive 3/2, negative 3/2, positive 1, or negative 1. So there are 4 solutions. Yes?
Why for your answer you get x equals plus or minus the square root of
Here?
yeah, that one, like, why you do plus or minus?
I'm doing plus or minus because if I say something squared is some positive value, then I know that there are 2 solutions. Because a negative times a negative is a positive, and a positive times a positive is a positive. So you have to consider both. Otherwise you're missing some solutions. That's why it might be safer if you know difference of squares, then you can't miss it. Because you would write 2x plus 3 times 2x minus 3 equals 0. If you recognize difference of squares. So this is like as long as it gets, this problem here. Because you have to do long AC method. Yes? That's a good question. Do we have to go back and check these? The answer is not necessarily, because I didn't have any fractional exponents where the denominator was an even number. Okay? I'm sorry, where the denominator was an even number. Like when we did, remember on the quiz, we had like the square root of something, and it said check for extraneous solutions.
Yeah.
And some of you that did, you checked, you got the square root of 100 equals negative 10. And for those of you that said, oh, negative 10 is extraneous. The reason is because the original problem, the square root of something, square root as an exponent is the 1/2 power. So the denominator was even. Okay. Now this is something that some of you may like, what are you talking about? How am I going to remember that? That being said, it's safe just to check your answers if you have time. The best thing you can do though is just be very careful, step by step, take your time, and just be very careful each line. And if you have time, you can check your work. You know, using a calculator, plugging 3/2 in to x, see if it makes it a true statement, plug in negative 3/2. Of course, negative 3/2 is going to be the same result as the positive 3/2, because look, once you go to the 4th power, it'll make it positive. Once you go to another even power, it'll make it positive. So if you test 3/2 for this one, you're also testing negative 3/2, because they'll both become positive as soon as they're input to the x's. So here again, so the big picture, just be careful. That's the most important thing. And if you have time at the end, you can check your work. But it's not necessary to check for extraneous when I have just a polynomial equation. There's going to be no extraneous solutions. Good question. So again, this is about as complicated as it gets. I think we all agree that this is about as nasty as it gets, because we had to do long AC, and then once you got to here, we now had to solve technically 2 quadratics. Okay? Now notice I did not use U substitution as I first showed you. You can if you want, but if you just look at this and say, okay, I know it looks like a quadratic, so when I get down to here, I know it's going to be, instead of something x plus or minus something times something x plus or minus something, it's going to be something x squared plus or minus something times something x squared plus or minus something, then you're good. So don't let the fact that it's, whether they're fractional or higher power, don't let that bother you. It's quadratic in form because this guy is half the power of this guy, and this guy is just a constant. So you can treat it just like you solve a quadratic. Okay, so now
I like that.
So if you look at page 169, number 52, we have this. Now again, you don't have to do U substitution if you can kind of just treat it like a quadratic in your mind. This student decided to do U substitution, which is fine. But it's a quadratic in form because this guy is exactly half the power of that guy. So, can we do short AC or do we have to do long AC for this guy? How do you know when you can do long and when you can do short AC?
Short AC is when the number is one.
Yeah, so short AC is when the A coefficient is 1, which it is. It's not written, so it's understood to be 1. It's implied to be 1. So this one, you can go right to it. It's short AC. It's factors of -6 that add to +1. And what factors would those be?
Whoa.
Factors of -6 that add to +1.
Oh, 3 and 2.
Which one negative though? 'Cause it's got to be
I thought you said
+3, -2, right? Because you need to be +1, and that's all you do. You can go straight there. You don't have to do U substitution. If you want, you can go straight to x to the 1/5 minus 2 times x to the 1/5 plus 3, because that's what you're saying U is. U is x to the 1/5.
Are we having one like that in the test?
Yes. You'll have more than one. You'll have 2. But they're just like you treat them like quadratics. Don't let them confuse you. They're treated just like quadratics.
I just don't know the rule for that.
You let U be this guy every time. That's the rule. This guy is whatever your this guy is here, without the B. That's what U is. Every single time. U is the variable component of this part here. Just the variable. Every single time. It doesn't change. Yes.
That one you.
That is 1U, yeah.
So what about, why did you put U squared?
U squared because what is x to the 1/5 squared? X to the 2/5.
I thought it would be like x.
No, 1/5 times 2 is 2/5. Don't get confused. Yeah, so then now you have this quadratic. Now if this is even nicer for you maybe, because it's like, okay, I definitely can see it's a quadratic. So I'm going to have U minus 2 times U plus 3. And then at some point you substitute back in for x to the 1/5 back in for U. Doesn't matter at what point. You can do it right now. This person decided to go ahead and let U equal 2 and U equal -3. That's not quite the way I would have written it. I would have written side by side, but U equals 2 or U equals -3. Then plug back in x to the 1/5 for U. So x to the 1/5 equals 2. X to the 1/5 equals -3. Here they're just showing that you could write x to the 1/5 as the 5th root of x. It means the same thing. You should be comfortable writing something in radical form versus exponent form. Yes.
Why did you change the 3 to -3 and that was a positive 3 again?
Because U equals -3 because that would make this 0, right? U minus 2 equals 0 or U plus 3 equals 0.
Wait, say that again?
U minus 2 equals 0 or U plus 3 equals 0. So if you solve for each one of those individual equations, you would find that U equals 2 and U equals -3. Then at some point you plug this back in for U. Plug it back in for U. You got x to the 1/5 equals 2 and x to the 1/5 equals -3. Raise each side to the 5th power to solve for x. X equals 32. X equals -243. Yes. Yes, you may. Any questions about this problem? Yes.
Okay, so like right when you said hit the x to the 1/5 power equals 2, right
Yes.
there and down. Down.
Okay. You don't have to write it like this. I'm just demonstrating that x to the 1/5 is the same thing as the 5th root of x.
Okay, so why do we write the x to the 1/5?
We write that because we're substituting x to the 1/5 into U. So if U equals 2, if I substitute x to the 1/5 into U, then x to the 1/5 equals 2. Just substitution.
Okay.
Yeah. So you need to raise both sides to whatever power so you get just x. So we raise both sides by 5 so you get just x on the left-hand side. For this one, we raise both sides the same thing by 5 to get x on the left-hand side.
I forgot, how'd you get x equals 32?
I got x equals -2.
32.
Oh, x equals 32 because x to the 1/5 is 2. So if I want to solve for x, I have to raise both sides to the 5th power. Because what's x to the 1/5 to the 5th power? No. X to the 1/5 to the 5th power is x. That's why I raise both sides to the 5th power. And 2 to the 5th is 32.
Oh, okay. And that x over there with that equals -3, that's still x to the 1/5?
U equals -3.
No, I'm saying over there.
X to the 1/5 equals -3.
Okay, yeah, make sure that's x for the 1/5.
Yeah, I know it's a freaking.
Mr. Gross, you lost me.
Yeah, you lost me.
Yeah,
That's fine.
Okay, so you have a question? I'd love to help. You have to be specific though. Yes. Did you get okay? This is the given.
That was given.
Did you understand U substitution?
Yeah.
Okay. Okay. Did you understand the factoring?
Yeah, you just like.
I'm asking.
Yeah.
You understand this? Okay.
From
So you.
squared and then from -6, yes.
So you understand that U can equal 2 or U can equal -3?
Yes.
Yeah.
I'm
Okay.
trying to figure out where you lost me. That's how this operates in there. Okay.
How do you get x equals?
Are you good?
Yeah.
Well, I'm lost too.
Okay. What's your question?
Come with her.
She understands now. So what's your question?
Like,
No, but
how'd you go from u equals 2 and u equals -3? Why did you get x equals 32 and x equals?
Because I substituted the x to the 1/5 back in for you to get this.
Okay, after you get that, what happens? Yeah.
Okay, I want to solve for x. I don't care what x to the 1/5 is. I want to know what x is. So how do I get x to the 1/5 to become x to the first, which is x? I raise it to the 5th power.
Square root.
No. I raise it to the 5th power.
Why did you square root it?
This is not a square root. This is the 5th root. I'm just showing that this is this. You don't have to worry about that. In fact, let's just do this. So x to the 1/5 is equal to 2. So then you end up raising both sides. So you have x to the 1/5. If I raise this to the 5th power, I have to raise the right-hand side of the 5th power. So x equals 32.
And by raising that side.
Because what's 5 times 1/5?
5 times 1/5.
Yeah, what's 5 times 1/5? I'm asking you, Mars. What's 5 times 1/5?
1?
That might be the confusion. It is 1.
It is?
It's definitely 1. That's why it's x to the first.
It's always going to be 1?
You want it to become 1 because you want to know what x is. Yes.
I got you. Do we know to raise it to the 5th power because of the denominator?
Yeah, and the numerator. So for example, let's say you get to, and this is an example, let's figure this out together. If I get x to the 2/3 is equal to 8, how do I solve for x?
You put an U on it?
No, we don't have to do U substitutions. We're at the very end
Oh,
here.
I know. Okay, use square, not square the 3 one, right? No.
So I want this left-hand side to become this. Do we agree on that?
Yeah. Is it 3/2?
It's the reciprocal. Yeah, so that's the big answer, whatever the reciprocal is. So I would raise both sides to the reciprocal, the 3/2 power. So x to the first would equal the 8 to the 3/2 power.
Why would you do that?
It's a reciprocal.
Because I want to know what x is. Because 2/3 times 3/2 is 1. Don't forget the rule, when you raise an exponent to another exponent, you multiply the exponents. You don't add them.
Why would you do the reciprocal?
Because a number times reciprocal is equal to 1.
I know that. Why do you both about it?
Because I want the exponent to become 1.
Oh, it's how many? Alright. And then what's 8 times 30?
And that part is not even really because the square root of 8 is irrational. So I would be if you left it like, I mean, you could leave it like that. I guess it's fine. It may get more simple, but the point I want to really focus on is this: the idea of raising both sides to some power to get solve for x. Just the reciprocal. Okay, so we got to move on. So that was that one. That was 52. Do you guys want to look at one more of these, or do you want to look at something else, the quiz, that is these topics here? So we looked at 2 of these, solving equations that are quadratic in form, linear inequalities, solving linear inequalities containing fractions, compound inequality, and we've done a lot of these recently, yes.
What was the one we just did? What kind of?
We just did solving equations that are quadratic in form. We just did 2 of those. The biggest thing I can tell you is just treat them like quadratics. It's up to you whether you want to use substitution. If you want to use substitution, go ahead and do that. It'll give you a perfect looking quadratic. Do long AC method if you have to, or tic-tac-toe if you have to. Okay, so then what do you guys want to look at? It's your review. Yes. The third one, solving linear inequality containing fractions. Okay. So an example like that might look like something like this. If I have 3x over 4 minus 2x over 5 is less than or equal to negative 1/5. Here's a linear inequality containing fractions. Okay.
You gotta make them all equal the same.
No, there's no equals. This is an inequality. But what you want to do is you want to solve for x. Maya, do you know what the first step would be? What you would want to do first? Okay, if I multiply the whole thing by 5, wouldn't that get rid of the fractions here and here?
Yeah.
Okay, would it get rid of the fractions here? Okay. So then you can multiply by 5 and multiply by 4, or you got the right idea.
I was saying, like, can you like set it equal like all the 20 or something? So then it will equal 1.
Even easier than that is to multiply by a number that gets rid of all the fractions right now. So what number can I multiply the whole equation, inequality by that would get rid of all the fractions? 20. If you're saying by 5 and by 4, that's the same thing as doing multiplying by 20. So let's go do that. Let's multiply the whole thing by 20. Let's multiply this by 20 and multiply this side by 20.
Well, how would that get rid of all the numbers?
You'll see. So 20 is the same thing as 20 over 1, right? So 20 over 1 times, if we distribute 3x over 4, minus 20 over 1 times 2x over 5 is less than or equal to negative 20 over 5. Are you guys okay if I just do that in one? Okay. All right, so why does it get rid of it? So watch this. So 20 is a multiple of 4. 20 is also a multiple of 5. That's why 20 is the least. It's a common multiple. It's also the least common, but it doesn't have to be the least. But it's a common multiple. So watch this. We're allowed to simplify. When you multiply fractions, don't forget you're allowed to simplify diagonally.
So then you got a 1 at the bottom and 5.
So divide by 4, you get 1. Divide by 4, you get 5. Divide the top and the bottom by 4. Over here, if I divide the top and the bottom, this 20 and this 5 by 5, this becomes a 1, this becomes a 4. And over here, this becomes just negative 4.
Oh, shoot.
Wait, what?
Negative 20 divided by 5 is negative 4. So edit, select all. All right, so if we continue with this. So now if you go, when you multiply fractions, we actually like that because you just go straight across. So you got 5 times 3x over 1, which is just going to be 15x, minus 4 times 2x, so minus 8x all over 1, is less than or equal to negative 4. Yes?
I was with you until you got less than equal to negative 4.
That's what we just did.
Negative 20 divided by 5 is not negative 4.
Oh, okay, sorry. I wasn't thinking about that. I was telling you, like, you know, I don't know.
What if you did like 40 instead of 20?
Okay, well, good question. It wouldn't matter. You would just be dealing with larger numbers that aren't necessary to be that large, but it would still get rid of all the fractions. That's a common multiple, but 20 is the least common multiple. So now you're here. Now this should look pretty comfortable. 7x is less than or equal to negative 4. And then the last step, divide both sides by 7. So the answer is x is less than or equal to -4/7. And then if the question said to graph this, how would you graph this? Somewhere on this number line, you got to write -4/7. And now when we graph this, x is less than or equal to -4/7. So is it a filled in circle or an open circle? It's filled in because it can be equal to it, and it's less than or equal to. You can take pictures of it if you want, but it's going to be available on Blackboard later today.
Okay. Well, we have one with some of equations.
Probably.
Okay.
Yeah. All right. Any other? You guys want to see any other problems? I have other ones on here. Any questions about this one? Yes. Mars.
Can we do another one where we?
Maya, please. We're still in the middle of class.
I
Yes.
just want to know if I didn't say anything.
What's that?
Can we do another one?
Of these?
Yes.
Sure. So you have. You can make it up. Make it up.
We can do any number,
Do anything you want.
but what if it come out like?
All right, I'll make it up. So you have 2x over 5 plus 5x over 3 is greater than or equal to 16. No, that's too large. I don't want to deal with that. 6.
Any numbers will work.
And you'll put a one underneath the 6?
I could if I want, yeah. I can make a 6 over 1. So the first thing is I don't like fractions, and most people don't like fractions, so I'm going to get rid of fractions immediately. So look at what I multiply this whole thing by to get rid of all my fractions.
15.
Good, 15.
Why not make this number smaller?
Product of 3 and 5 is 15. That's a quick way to do it. But that, and even if it's not the least common, the product is always going to be a common multiple.
You're trying to, you're trying to simplify so you get one on
All
like
right.
the bottom.
So when you do this, 15 and 5, 15 divided by 5 is 3. So I have 3 times 2x plus 15 divided by 3 is 5. So I have 5 times 5x is greater than or equal to 6 times 15, which is 90.
Okay. Where will we go from here?
So I have 6x plus 25x, which is 31x, is greater than or equal to 90. Divide both sides by 31, so x is greater than or equal to 90 31st. 6x plus 25x is 31x.
Okay, I get it.